Thanks for hanging out here for my talk. I know it's been a long day, so what I'll be talking about today is IoT security and also how to break into IoT devices. The first part is going to be the boring part with statistics and that kind of things, and then we're going to get into the more technical aspects on how to break into actual devices. And there's many different ways and different things you need to know when you do IoT security. But for this talk, we'll focus on JTAG, and we'll talk a bit about that. And my hope is that when we're done, if you've never done this, you should be able to understand why IoT security is important, and to be able to at least get started in that area. So the agenda, we'll talk a bit about who I am, what IoT is. Again, I said we cover some statistics. Some of them come from a study Trustwave conducted last year. We'll talk a bit about what IoT security looks like nowadays from the field. And then we'll go into attacking IoT device, JTAG, and then finally what organization as well as developers of IoT device can do in order to better protect those devices. Well, that's right. So this is an entry-level session. Ideally, if you don't know anything, you should get something out of the talk, and hopefully, even if you do know some material, maybe you'll pick up a thing or two along the way. We'll start by clarifying what IoT is and isn't, and because we have to do this quickly, I think I'll skip a few items on there. I am Michael Chamberland, also known as Mike. I'm the practice lead for Trustwave Spider Labs in the North America region, and actually that just changed recently. It's now the Americas region. I'm a collector of certifications. I've been doing a whole bunch of them for a while, and I grew up in Sherbrooke, Canada, so if I have a little accent, you'll probably not notice anyways, but I grew up speaking French, and English is also my second language. I now live in Sarasota, Florida, and I work with all Spider Labs resources very closely. We have a team of testers that routinely do a lot of IoT testing. We do just all kinds of things, doorknobs and ATMs, cash recyclers, and many devices like that. What Trustwave Spider Lab is, it's a division, Spider Lab itself, it's a division within Trustwave. We have over 150 specialized security experts, and we focus on the fun stuff when it comes to security. We don't do the boring defensive stuff. We focus on breaking things, penetration testing, incident response, as well as research. We perform millions of scans, thousands of penetration tests, a large number of red team engagements, and that's essentially what I'm bringing here is information from what we learned doing those very large number of tests and sharing that with you. And also, just so you guys know, we have an office in Makati, and I think I said that wrong every time, Makati, I think that's right. But we have an office there, and we're hiring pen testers, so if any of you guys are looking for that, definitely reach out. We'd love to hear from you. So the first part is, what is IoT? IoT is, well, we'll start by talking about what an embedded system is. Computers are really built to do general computing purposes. An embedded device is really built for this specific purpose. For example, you might have a watch, and it uses electronics to function, and really all it does is show the time and show the date and things like that. So that's what we call an embedded device. It has a dedicated function, it's not general, and it typically is not interconnected with other devices. So an IoT device is actually the same thing. It's an embedded device, but the difference is it's actually interconnected. It's usually done over the internet using IP address, but not necessarily. Very often when you purchase them or when you see them marketed, they're marketed as smart devices. An IoT device is always an embedded device, and the opposite is not true. an IoT device that's interconnected and it's built for a specific purpose. Just so we're clear here, we're going to go through a few of them. Nest thermostat would be considered an IoT device, Ring doorbell, Amazon Echo, and even we see pool systems that are controlled using mobile devices, websites, and whatnot. Door locks, and there's a whole array of different things you can do, like light switches and lighting system, watches, blood pressure monitors, etc., etc. So it's a very large realm of devices that belong within the IoT domain. What's important, the growth of IoT both in the home and the enterprise has been growing explosively. And it's still in its infancy, and there's not very many security standards around, so you're able to find a lot of issues that in other areas, like in network security or web application security in general, it's harder to find, but in IoT people are quite behind, so it makes it easy to find these kind of vulnerabilities. The field is very young, and there are some testing methodology out there, but they're not very mature and robust. So there's a lot of research that needs to be done in that domain still today. So some example that shows the impact of some of the attacks that have been done involving IoT devices. There was one where it was a casino where they were using a smart thermostat in the fish tank in their lobby, and that was connected on the same network as all their imported system. So the hackers were able to use the thermostat from the fish tank to get records on every customer's from the casino. StepNext would be another one that was interesting because it was really not connected, but it was embedded systems. Essentially what the attacker, who we still don't know who it was, but they were able to destroy a centrifuge and delay the nuclear program for the Iranian government. So it was a very sophisticated attack, and it really had quite a big impact. Another one that's interesting is the Mirai botnet. This was a very, very large botnet, and it was known to have caused the largest DDoS attack at 1.1 terabits per second, and it was composed of mostly IoT devices. And it just took advantage of simple stuff like default credentials and missing patches on the typical IoT device like IP cameras and network routers. A few more examples here are, those are not actual attacks that happen, but more proof of concept that we've seen. Cardiac devices and insulin pumps, that the impact on those, being able to hack them, could cause incorrect pacing on a cardiac device or shock the patient by draining the battery of the device. Also, the insulin pumps, an attacker would be able to cause an overdose of insulin to the patient. So those are pretty high-risk items, so it shows the importance of taking security seriously when it comes to embedded and IoT security. Another one that I'm sure just about everybody heard about is taking control of a connected car. Initially, we saw some primitive control, but as the car become more and more connected, now they're able to remotely control the cars and steer them, apply brake and gas and whatnot, and drive into the ditch. So it shows just how important that is. And I'll skip here to save some time. Next portion here, I'll talk a little bit about a study that TrustWave did about IoT security to understand how organization took IoT security seriously and see what security practices and implementation challenge they had. This study was conducted by Austin Research in November of 2017. There was 137 respondents, and we targeted mid-sized to large organizations within North America. So one thing that was very interesting is there was a lot, like 84% of organizations are already using IoT, but very few of them were thinking that IoT security was very important. So they're leaving this huge door open to hackers in their environment by not really paying attention to IoT security as they should. Also, they stated, one of the biggest reasons that they were reluctant to add more IoT in their environment was because of security concerns. And also a very large number of them had experienced IoT-related security incidents in their environment. So the threat is there, the threat is real, and there's a significant impact to having IoT in an enterprise environment. Also, we found that a large number of organizations have a really good patch management program that included IoT embedded devices as part of their patch management program. And last but not least, they seem to rely very much on internal security as opposed to engaging vendors in order to test and validate that what they're deploying is actually as secure as it can be and tested thoroughly by a third party. So in order of setting some speed here, I just have some additional study statistics from other organizations outside Trustwaves, showing just how much IoT is growing. Business Insight Intelligence projects there'll be 55 billion IoT devices by 2025. Juniper, 46 billion by 2021. Cisco going to 26 million by 2020. All these organizations are around the same numbers, looking at the growth, and it looks like it's a growth rate around 20% between now and 2020, 2025, or something like that. So there's definitely a huge field out there. There's going to be more and more for folks to look at. So I think it's a really, somebody that wants to specialize in something, it's a really good area to learn and be good at and help secure that environment. So we now have a OWASP top 10 since 2014 for IoT security. What it goes is insecure web interface. Essentially, a lot of IoT deployment has a web component to it, and very often that web interface can have vulnerability. Authentication and authorization is usually not implemented very well. You got insecure network services. Sometimes it could be because they wrote something from scratch and they have to relearn how to write something securely, or they're using some very old software that hasn't been updated on their device. And then we see a lot of issues around not using encryption correctly, transport encryption. And there's also privacy concern because of all the flaws in those devices. We're concerned about people leaving private information on there and then being exposed because the security is so lax. Also, very often cloud interfaces are involved, and those also have vulnerability, just as mobile interface and do as well. Another item is not enough options to configure security. It's just come out of the box and you use it. You don't have options. All right. So yeah, the next item is security options. There's not going to be enough ability to turn on encryption or have it on by default and things like that. Also, insecure software and firmware that the firmware is not protected and can easily be extracted and reverse engineered. Also, that there's no secure way to actually upload the firmware to the device. And finally, poor physical security. Essentially making it easy to reverse engineer the hardware, extract the firmware, get stored secrets, and reverse engineer the source code and whatnot. So what we've noticed as attackers of those devices is it looks like the security is about 10 years behind. on those devices on average. Not all of them, but most of them. And we see a lot of things like weak credentials, default credentials, replay attacks, which mostly have been solved in other areas, are possible within the realm of IoT devices. And encryption is very often not used, or when it is, it's not done correctly. And also another issue is very often it's implemented in a way where you can't patch it at all, or to do it is very difficult, especially from an enterprise environment to be able to manage. Also, another challenge is it's a very large ecosystem. There's so many different connectors, standards, and platforms that knowing it all and being able to secure it all takes a lot of knowledge and a lot of work, and it makes it a little bit more challenging. And then we also notice that a lot of embedded developers think that what they're doing is magic, and that nobody's ever going to figure out, how their stuff works, and they're not going to be able to reverse engineering and break into it. And essentially, they rely on security through obscurity. So now to the more fun part, we're going to jump into attacking IoT devices. The IoT stack is very wide. It includes, when you're testing an IoT device, you're not testing just the device, but you're testing the device and everything else that lives around it. And that includes all the user management interface. Sometimes it can be mobile apps, web application, or thick client application. You have to test all the hardware inputs and outputs, and that will vary for each device. Sometimes you have different sensors and certain switches and buttons and whatnot, screens and keyboard or pointing device and whatnot. So all these, and there's also a lot of different wireless protocols being used, like Bluetooth Low Energy, Zigbee, Wi-Fi, etc. And that should all be part of your test plan. And also, just as a typical network device, you will test it at the local network level and layer 2 level, as well as in the network level over IP, if it's over IP. And last but not least, cloud services or APIs that the device makes use of should also be in scope for your engagement. So what that means is, as a tester, you need to have quite a few skills. You need to know how to do web application security. You need to know how to do mobile application security, wireless testing, network pen testing, reverse engineering, electronic. And you have to have a strong appetite and aptitude for learning. And again, the reason is because this ecosystem is so large. You're most likely, every time you're going to see a new device, you'll find a new chip in it, you'll find a new protocol in use, you'll find something new, and you have to be able to learn it real quick and figure out how it works and whatnot. So here's what it looks like at a high level. This is a data flow diagram that could be used for threat modeling. And this is just an example, but when you start testing, you'll want to do that. You figure out how the data flow between all the devices. Here you have a web browser that interacts with a web application, and that web application talks to an API, and that API interacts with a data store. And then the IoT device works directly with the mobile application. And so you want to draw something like that to understand how the different components all work with each other, and then you try to identify threats at each of those components and how they communicate and work with each other. So one of the first steps you'll do is research your target. You'll want to identify the hardware components that are being used. That will give you a clue as to what the device does and how it works. You'll be able to, once you identify those hardware components, you can download datasheet. If it uses any wireless on the device, then there's going to be a FCC ID assigned to the device, which you can find on the board somewhere. And then you can go and download information in the clients for that device and learn a lot about it. So a good website to do that is All Datasheet, but there's many other websites you can use. You probably want to get a magnifier, maybe a USB magnifier or just an i1, because sometimes reading on those chips, the numbers and the model numbers is difficult doing with the naked eye, actually impossible. So that's what you want to do, look it up. And then you learn a lot more about the pinouts on those chips, and you see, you can be able to sometimes trace where it goes and connect to stuff that way. You'll want to download any firmware and try to reverse engineer that. Download any SDKs and learn how to interact with that SDK. And then identify all the different ports, all the inputs and the output ports on the device. If you get to the point of you found a vulnerability and you're looking to see the impact that vulnerability could have if it wasn't employed, you can move to show them and just start looking for how many of those devices have been deployed out there that might be vulnerable to what you just found. So the most common attack techniques that you would do is reverse engineering your firmware is usually one of the first things because you get so much out of it. If you're able to get to the firmware and reverse engineer it, very, very often you'll find hidden secrets. And what I mean by that is passwords that are input text or certificate used for authentication, API keys and whatnot. And then you can use that information to further attack other component of the solution. And you might be able to find backdoors. Actually, we found a backdoor in IP camera that was made out in China. It's actually the firmware that was used for a whole bunch of different cameras, and they were all using the same code. So we found a backdoor in one of them and able to take advantage of it, reverse engineer it in the SSH client, and then basically you can get root on any of those devices. They're all sharing that same firmware that have this built-in backdoor. Another thing too is you can get debug information or administrative features by logging into the device that lets you learn more about its internal working and hopefully take it further to your goal. You can do radio attacks that include sniffing traffic, replay attacks where you might monitor a component talking to the other and then just replay it without knowing what it's actually doing, just replaying it and successfully issuing commands and whatnot. This is something that's largely been fixed in other areas, but we still see here. Again, I guess that's redundant, monitoring network traffic and sniffing. You can port scan the device and look for anything that's running on it. And using that information, you can identify any services that might be an entry point into the device. And then another thing that you'll want to try is access the device memory directly. So there's many different kind of ports on IoT device, and most specifically debug port. URT is a big one. It's a serial port where often you can connect to the device. JTAG is the one that we're going to jump into more detail. But over time, if you don't already know about the other types of port, SPI, I2C, USB, Ethernet, etc., obviously you'll want to learn about those as well and see how they can help you get into those devices and troubleshoot them or extract memory and things like that. So here is the fun part, JTAG. And this section is a little bit thicker than the other one, so I have a little breakdown here. Initially, we'll talk about what JTAG is, how it's used, and then I'll talk a little about how it can be used as an attacker's perspective, and then helping identify pinouts so you can interact with a JTAG port, and talking about the different ways to interact with it after you identify the pinouts. So JTAG is named after the Joint Test Action Group. It's an industry standard for verifying printed circuit boards, and it's very often used in production when they want to test those boards. And it's also used for RMAs when you send a defective product so it can be retested or refurbished, actually, and resold. It defines a debug port, and it allows to tap into the PCB and see what's happening in it while it's in operation. And the way it works is you get one port, and you're able to daisy chain all the chips on that board, and you're able to read from all those different components running on the board, as opposed to having a separate port for each one of them. And very interestingly, it allows you to debug the firmware code as it's running, which is a very useful feature, and it allows boundary scans. The main pins that we're interested in on JTAG are the TDI, TDO, TCK, TMS, and TRST. And the TRC is not always there, so it's either going to be 4 or 5 pins that you need to identify on the board. And once you identify which one is which, you'll be able to do this debugging and looking at memory and things like that. So JTAG is typically used to, in the formal use of JTAG, not as an attacker, but formal use is to extract and upload code/data to the device, modify memory contents, affect the device operation on the fly, as well as read specific pins on the device that's on the circuit board. As an attacker, what you'll want to use JTAG for is to download firmware. Once you download the firmware, like I mentioned before, you can take it apart, start analyzing what it does, and look for things like that. Also, you'll want to upload firmware using JTAG after you tamper with it, or maybe create a backdoor. You'll use it to debug. I think a good example of debugging is you might have a console access, and but yet it's password protected, and you potentially can set a breakpoint on a string compare function. And as it's going through, you can step through it and figure out what the password actually is that it's comparing to in some of the primitive systems like that. And ideally, if you're doing this as part of a larger engagement, like a team engagement, that might just be your first foothold into the network. And from that point on, you can use it to pivot further into the network. So, identifying pinouts. The main challenge of leveraging JTAG, again, is determining how to connect to it. So there's different methods of doing this. You can do it either visually, like trying to trace the pin, knowing what chip it is and what pin on the chip are the JTAG ones, and try to identify where it goes and then connect to it directly. Or you can use software. There's other commercial solutions out there. For the purpose of this talk, I just covered 2 of the most popular ones that hacking community is using. That would be JTAG Enum and JTAGulator. So visually, sometimes we get lucky, and once in a while, you'll see the port will be labeled as a JTAG port, and it will make your life very, very easy. You might be able to find information online. For example, Linksys routers are very well published. You can go online and look it up, and there's other people that have already done the work for you, so you're able to just leverage their work to find where that port actually is. And sometimes it's not so easy. Here are some standard ports that are used for certain chips. So if you see that a specific chip is being used on the board and you see a header that looks like these, there's a good chance that you'll be able to leverage that header and connect to JTAG directly. And so that's another way to do it visually. One of the things you want to do most of the time is you're going to need to add headers, like the little black thing there with the pins, so you can connect to it. There's also clips that you can use and clip on directly into the board, so you don't have to solder anything. And also, as you're preparing, you want to identify the target voltage so that your equipment actually matches that voltage. So to do that, you can either look up the data sheet for the device, you might be able to look at the power adapter of the device, or measure the input versus the ground to identify what the voltage is for that device. There's some precautions here if you don't want to fry your equipment. You want to make sure that there's shared ground between the target and the device you're using to enumerate. And then you'll connect the target with power off, and then you'll power off your tools first, and then the target device that you're testing. So here's an example of a JTAG port on a Linksys router. You can see there's no headers attached to it. And once you have identified it, you want to add your own headers. That would look like this. And then you're able to connect to it. And sometimes other people do it like this, which is not recommended because it's kind of hard to undo. And so once you've identified what could be the JTAG ports on your board, now you need to figure out which pin is which. in order to work with it. So what you'll do is you'll use one of these tools. One of them is JTAG now. It's free. It runs on Arduino, and depending on which board you're using, you can do up to 46 pins. So that's one of the really nice things. If you're using a TNC++, you can do 46 different pins. You can kind of go all over the board, let it go nuts, and tell you, what it thinks is each pin. There's also a new version that came out last month that runs on Raspberry Pi. I haven't used it, so I can't really comment on its reliability and whatnot, but it's out there for folks that would rather do it using Raspberry Pi. Both of them are very simple scripts. You just have a few things you can configure at the top of the script, and then you start using it. The JTAG enum also allows you to identify pinouts for UART. One of the caveats is that it works sometimes. It's not the most reliable solution, so sometimes it's useful and sometimes it just gives you garbage. The next item is JTagulator. It's open source design. You can buy it pre-built or you can build it yourself. And it can do up to 25 pins. And again, it can also do UART. And what's nice about it is a little bit more reliable than the Arduino solution. And then let's assume now we use one of the two solutions out there, or you can visually identify where our JTAG port is. The next thing you want to do is you want to interface with it so you can do the debugging and the monitoring and downloading firmware and whatnot. So to do that, the two main programs being used in the hacking community is your JTAG and OpenOCD. Your JTAG is very simple. It allows reading and writing firmware, but it doesn't do debugging. And it works with VSDL files, so you have to have the chip definition basically loaded on in the right folder for it to actually identify them. And then when you use it, two of the main commands you'll use is cable to configure your cable that you're using, and then detect to actually let it go and scan the chain, and then it'll let you know everything it finds on that chain. The next one is OpenOCD. That one is a very featured tool. It has many different options. Support reading and writing to flash memory. It lets you do live debugging with GDB, which means that you can run a version of GDB that supports the architecture you're trying to debug through OpenOCD and step through the code and set breakpoints and whatnot while it's running, which is a very nice feature. I won't go through too much details, but I mentioned the slides will be available later. If you do that, it talks a little bit here about what tool to use and how to configure GDB to have it connect to OpenOCD so you can actually debug through those. And then obviously you need some hardware to do this. There's many different dongles available that you can use. Sometimes it might be a little bit confusing to identify what to use. A lot of them are based on the FTDI FT2232 chip. And basically that's a USB to JTAG adapter. There's many different versions of it. One that I like is FT2232H. The first two stands for 2 channels, and the H at the end means high speed, so it's high speed USB. And you're able to connect it to 2 different things at once. So if you want to do JTAG and UART at the same time using one cable, which is kind of nice. And at the top right here, you can see kind of how it works. You have it on your PC, and you have OpenOCD running, you have the FTDI driver installed, it's connecting over USB, and then assuming you identify the TCK, the TMS, TDM, and TDO on your board, you connect to it, and you power on the board, and you'll be able to start interacting with it, downloading and importing the firmware, as well as debugging while it's running. So let's assume now that you've actually got to, you're connected and you're able to interact with JTAG. You've downloaded the firmware. I just wanted to share a few things to look for or try next. Binwalk is a tool that's very useful. You can feed it a firmware image or actually any file, and it will identify what it sees as file systems or file types, and it'll allow you to extract those. So typically, the whole firmware is going to be a collection of things. There's going to be compressed kernels, different file systems, and whatnot. So in order to analyze it, you'll want to use something like binwalk to identify what is what and extract it. One of the things that is not so great about it is it's signature based. So sometimes it will see something that it thinks is maybe a kernel, but it's not. It's just because it was looking at signature and it was misinformed and made a bad guess. So we have to be aware of that. Firmware mod kit is just a tool that allows you to extract firmware, and then you can tamper with it, put your backdoor, whatever you want, and then it will reconstruct that firmware so you can upload it to the device. And it takes care of doing the compression, updating headers, and resizing file systems and whatnot. And last tool I wanted to talk about is FirmWalker. Once you have your hands on firmware, this tool will do a lot of the things you might do manually otherwise, to look for passwords, certificates, keywords, web servers, and whatnot. So it'll find a lot of the low-hanging fruit for you just by running it against extracted firmware. So last section is about handling IoT growth. Just a few recommendations for both organizations and implementers. If you're an organization that deploys IoT, which you probably are, you want to define and implement IoT security policy. You want to make sure you manage your IoT inventory, not just let it go a while. You need to know what it is that you have so you can manage it. And also you need to have a solid vendor management program in place, not only for IoT, but in general you should. But it should cover IoT as well, so that when you're actually bringing those devices that are bought from vendors that you've vetted as having a solid security program. And then obviously you'll want to regularly scan and test those devices like you do with the rest of the environment. And most importantly, like the fish tank story we had earlier in the casino, you'll want to properly segment those devices to a separate region of your network, so that if they do get compromised, they don't affect other system and environment moving forward. And then as a implementer of IoT device, you want to make it as hard as you can to expose debug interface, so that an attacker has quite a hard time getting to it, and maybe they'll move on to the next target that's a little bit easier. You'll want to validate firmware that's uploaded to the device to make it harder for people to tamper with the firmware on the device. You want to use the principle of least privilege. We see a lot of stuff that everything's running as root, everything is a super user, and it's not really necessary. If you run things that are lower privilege and it gets compromised, at least you don't give out everything right off the bat. So it makes it harder. So it's really important to run services with the least privilege they need. And don't assume that your code is running in a trusted environment. That's a big one. Because security through obscurity is not going anywhere with IoT. And again, the biggest issue we see, or very common issue, is default credential. Make sure you use strong password policy and not default credential. Have a solid update mechanism in place, because once you let something out and you don't have a good strategy to update it, then it'll be a nightmare, because trying to email patches and whatnot, and maybe sometimes you don't even have any way to update it. So you have technology that's out there in the field that can't be updated and has a vulnerability, so customer only one option is to retire it, which is probably not good business. So, and also we see a lot of encryption issues. People are not using encryption correctly, so it's important to manage keys properly, using the right ciphers and whatnot. And also, it's important to design stuff with security in mind and to test it internally, but you should also rely on a third party to fully test the solution. So, in conclusion, there's many types of IoT devices on the market today. There's a huge amount of growth, and security in IoT is very young. So there's a lot of opportunities for folks that want to work in that field and help improve security for IoT device. So It can be difficult, but it's a lot of fun. So hopefully, I've whet your appetite, and it's something you'll be interested in, and can contribute to improving security of IoT devices for everyone. So pay attention to IoT. If you want to reach out to me, my email's there. mchamberland@trustwave.com or SecurityWire on Twitter. And salamat. Pahalam.